Okay, we're broadcasting live from second period. A lot of times when you first get the calculator, especially if it's not yours, it's in some kind of weird window, and I like for you to know how to get it back to kind of normal. So to get it back to kind of where it's 10 by 10, if you hit zoom and then you go down to standard or hit 6, it'll get it back to kind of a normal window. So if somebody's gotten some kind of weird window where it's way out and you're like, I don't know how to get it back, that's the way you kind of get it normal. So most of you probably started with something like this, which not everything's on the graph. So any suggestions about how we fix that? So that I can actually see more of the graph. How do I fix?
The window.
Okay, so I go into window, and my suggestion is for most of these that we're going to do in this class, a quick fix would be just to change the y min and max to like -100 and +100, because usually your x's are going to be okay. I'm going to show you how to be more specific, but this is kind of a good way to kind of zoom out and see, well, I can't quite see everything. So if I change my min and max, you don't have to change the scale. It'll just look nicer if you change the scale to tens. And then if I go back and graph it, I will see something where I can kind of see, at least for this particular one, the whole graph. And once again, for our viewers at home, we're doing 2x to the third, 6x squared, minus 20x, minus 48. Okay, so that's that. Now, very often, the graph that we get is still out of the window, or maybe I want to zoom in a little better. So I'm going to show you a different way to kind of figure out, well, what's a good value? So some of you may or may not know this key even exists, and it's important that you know it exists. If you do second and table, it'll actually bring up a little table of all the XY values. And if you kind of scroll through that table, what you'll notice is, okay, it's at the 8, you can tell it's kind of going off in the distance. But then it goes all the way back down to -60, and then it comes back up again to +12, and then it turns around again and starts going off in the negative direction. Okay, are we with me here?
Yes.
Okay. So by looking at that, I can say, oh, my minimum value looks like it's about, or my maximum value looks like it's about 12. My minimum value looks like it's about -60. That would be a good window to put this in. So I'm going to tighten my window up a little bit and say, okay, I want to go all the way down to -70, just below that -60, and I want to go all the way up to +20, just below that 12, and that's going to tighten up my window to fit a little better. So -100 to +100 is kind of a good zoom out kind of stage, but you can look at the table to kind of get that to fit a little better. All right, so one of the things we're supposed to do is figure out the zeros. So can anybody see what my zeros probably are there? Looks like -4, -2, and 3. So I'm just going to assume that's right. So -4, -2, and 3 is probably where my zeros are. Anybody got a suggestion of how I could better figure out if they're actually at -4, -2, and 3? Other than just looking at the graph. You could zoom in. Okay. Does anybody know how to actually? Some of you probably know the trace function or not. What's the trace function do?
It lets you move your cursor along the line.
Yeah, if you hit trace, the arrow button creates a little cursor and you can move back and forth. So left, right, you can go up there. Now here's the problem. Right there, I'm like, oh, it's at -3.8, it's at -4.04. It's like, well, it looks like it's about 4, but it's really hard here to tell if it's exactly 4. Okay? It looks like it's -4, but I'm like, well, from the graph, it's kind of hard for me to tell. So has anybody got another suggestions that I could figure out, like, is it exactly -4, or is it just close to -4?
I don't know.
Okay. Well, if it's an integer value, where did we just see integer values just a second ago?
Table.
Table. If we go back to table, oops, I didn't hit table, hit graph. If I go back to table, I can look through there and say, oh yeah, -4 exactly is at 0, and -2 exactly is at 0, and 3 exactly is 0. So this works if they're integer values. I'm going to show you how to do it if they're not integer values, and it's going to be related to how to find the local minimums and maximums. So this is the big trick I'm teaching you today. Other than if you don't know trace and table, those are also good tricks. So I'm going to go back to my graph. Oops, my graph. All right. I want to just double check. Let's pretend I didn't know about the table, but I want to double check, like, what is my 0 right there? What's the exact number? So here's your trick for today. If you do second and trace, which is actually calc, second and trace will give you this little calc menu. And it says, oh, do you want to plug in a value? Do you want to find a 0? For some of you, 0 says roots, depending on your calculator. Do you want a minimum, a maximum? Next week, we're going to have 2 lines crossing. You can find the intersection. So I want to double check my 0 there. Pretend I don't know what table is. So if you click, I went second, trace to get this menu. I'm going to do 0, number 2. And then there are 3 zeros there. The calculator is not smart enough to know which one I know. There is no brain plug-in yet. So you have to say, I'm going to define a little window. You have to say something on the left and something on the right, and then roughly where you think the answer is. So I'm going to say to the left of what I'm looking for is here. I'm just moving my cursor over. It's asking me a little question down there, left bound. So I hit enter. And then it says, okay, what's the other side of it? So I'm going to move it up so it's on the other side of what I'm looking for. That's my right bound. And I hit enter. And then it says, what's your guess? Where do you think that answer is? And well, I think it's about right there. So I hit enter, and it's thinking, and it's thinking, and it's thinking. And it says, oh, your 0 is exactly -4, 0. So this is really useful if it's not exactly on a number. If it's like 4.1, and this would find 4.1. Although, so in the table, we can find -4 really easily. But if it was not exactly -4, this is the way we'd find it easily. The real reason I taught you this trick is this is how we're going to find out what this number is. So somebody tell me what number they think that local maximum is.
Y or X value?
Both.
I'd say like X -3, Y 1.3.
Your Y is...
Oh, wait. Oh, I'm in a different thing.
Okay.
My bad. Because I'm in window 100. Like Y, like 13 or 14.
Yeah, well, if you look at the bottom here, X equals -3 probably, and about 12. So this is close. -3, 12 is close. We're going to use the same trick to find out what exactly is that local maximum. Once again, this is called a local maximum. It's a maximum amount within kind of a local area here. So we're going to do that same trick. Second, calc, we're going to say I want a maximum value. I hit enter. And I'm going to say, okay, it is not smart enough to know which what area I'm looking at, so I'm going to move a little bit to the left because it's asking me left bound. And then it's going to say, okay, what's your right bound? I'm going to move to the other side of my answer and say enter. And then it's going to say, what's your guess? And I'm going to say, well, I think it's about right there. And then it's going to think. And it's going to say your maximum value is exactly -3.081664 and 12.082221. I don't need all those digits, but if you do it this way, show me at least 2 digits. Don't round it to -3 and 12 because you can do that just by eyeballing it. I want you to show me that, hey, I used the calculator, I found the exact amount. So in this case, when I draw it on our graph, which people who are listening to this on the internet can't see, my local maximum is going to go up to, our local maximum is -3.08 and 12.08. All right, real quickly, just because we haven't asked it, can somebody use the trace function to figure out what the y-intercept is? I think it'll land right on top of it. -48. Let's see, trace. I go down here, and in this case, I think, yeah, it lands right on top of it. I don't know if it will always do that or not, but in this case it does. So -48 is my y-intercept. All right, I want you to use the same trick that we just used to figure out this local minimum. It's going to be somewhere around 1 -60, but I want you to use that second trace function to find out exactly what that local minimum is right there. And I'm going to stop my online version now.